Thank you for the opportunity to speak. What we're going to like to talk about is how, and Paul did a great setup for me really about sort of the wetland inventory work that we've been doing with DU, and we're slowly taking this information and let's use it as a tool to help us make decisions. And in this particular case that I'm going to use is the work that we did on some roads work with a group of people, many of which are here in this room today. So I'm going to talk just very briefly, and there's a lot of people that know about classification systems here, but I'm going to just give a bit of an overview from my perspective and work experience. Talk about the wetlands and roads work we've done. Talk about the previous work that we've done and current and future initiatives, because this is not going to stop here for us. I'm going to start off with forest inventory and wetlands, because that's where I got my first exposure to wetlands. And as was mentioned by Paul, it's largely focused on the productive land base. Some of the productive land base was and is wetland, and such as black spruce swamp, which is perhaps not as common in the west, but it's very common in eastern Manitoba and into Ontario. Features without merchantable timber were typically described as muskeg and or string bog. And this, if you want to understand how wetlands work, it really does create significant challenges and difficulty in determining the type of wetlands that are out there, which is, we're realizing more and more, is really critical. If we want to talk about wetland classification, historically there's been no universally adopted wetland classification and mapping system in Canada, and I think that speaks to our country really. We've got everything from marine environments, wetland environments to montane, the Boreal Plain, Boreal Shield, the Cordilleran, all the way over to eastern Canada. So it really has been a challenge for our country to have a wetland mapping system. The three primary systems have been used, I would argue. The Stewart and Cantrell system, which is designed for prairie ecosystems. The Coarden system, which was developed in the U.S., deals with a lot of wetland systems that are right across the lower 48 as well as Alaska, which is a step up in terms of inclusion of boreal. But really, at the end of the day, the Canadian Wetland Classification System, which was designed by Canadians for Canadians, is becoming the standard. But it doesn't matter what classification you have, there really are challenges in mapping wetlands, and that's been a focus of our work for as long as I've been with DU. So as I said, increasingly the Canadian Wetland Classification System has become the basis for wetland classification systems across the country. It has 5 main wetland classes. There's bog, fen, swamp, marsh, and shallow open water. The difference between shallow open water and the lake is that it's under 2 meters deep. And then it breaks it down into formed and subformed. The benefit of the Canadian Wetland Classification System is that there's a wider suite of ecological characteristics where inferences can be made. Things such as water movement, pH, soil type, soil depth, that type of thing. And that's the benefit of having an ecologically based classification system, and which became the basis for the classification system which we had developed and are currently using within DU Canada. And what's really key to this is that at the end of the day, not all wetlands are the same. They don't have the same soil depth, they don't move water in the same way. There are different ecological characteristics. So it's really key. So when you have that map that says muskeg, my experience is muskeg is a combination of bogs and fens. They function very differently. For example, bogs are stagnant systems. They receive their water and their nutrients through precipitation, either snow or by rain. Fens are also very deep organic wetlands like bogs, but they are much more nutrient rich, more diverse in vegetation, and if we're talking about road developments, they move water, a lot of water, very slowly and laterally across the landscape. Swamps, which are arguably the least understood wetland systems in the boreal, we call them seasonally fluctuating, and this is a picture of a shrub swamp which Paul talked about. But what we mean by seasonally fluctuating, they have seasonal fluctuations vertically when you have spring runoff or a heavy rain event, but they also have moving water laterally. And so that's really important if you're putting in a road, to have that understanding that's not going to be contained within that stream channel. There's going to be more movement of water vertically and horizontally. Then we have the two sort of classic wetlands that most people are familiar with, are marshes, which are periodically draw down. They typically dry out on a regular basis. That's why that vegetation gets established in the middle of the water through the drawdown cycle. And then the shallow water systems have surface waters that fluctuate on an annual basis or semi-annual basis or seasonally for a variety of reasons. So from our perspective, and I think we're learning that by understanding the fundamental differences between these systems, and in this particular case I'm talking about water flow, can really be informative and be used as a tool to make smart decisions. So I'm going to talk now about roads and how this information has helped us. Roads and other linear features may impact wetland hydrology. In fact, it's more common than not common. And everyone, I would argue, around this room has seen these types of things. We've got a rail line on one side over by Hudson Bay, Saskatchewan. And then this is a picture from northern Alberta where there's a road development, and just where the arrow is, that is blocking the flow of water. And there are ecological consequences of this. You've got the drying of the system downstream, the wetting up of the system upstream. There's probably a whole lot of things that are happening out there. Water movement to the wetlands downstream, nutrient loading, fluxes in carbon and methane. There's a lot of things that are going on when you interrupt the flow of these natural systems. This is just an example of a road that was built across a treed fen and fens have slow lateral flow, and this was the year one of that road, and already you're getting wetting up of water coming up against the shoulder of that road as a result of the lack of understanding that they were in a treed fen system and that there was going to be lateral flow. And for those of you that get involved with road maintenance, you can appreciate some of the challenges ahead. So wetlands may impact roads though as well, and what we've observed, and thanks to some of the contributors of these photographs, is that you end up with wet subsurface roads under the road. You end up with rutting going on, capturing water. Now you got to resurface that road with more gravel, or perhaps tear the road out and put in a culvert. You have sinking culverts in deep organic wetlands that oftentimes get plugged. We end up with blockages that cause flooding, which cause operational challenges when you have to access the resource that you're trying to get to. And then you end up, so that's not a good thing from a cost perspective, and certainly keeping operations going. And then there's another element that we'll just speak about, is wetlands and safety. And it's kind of a funny picture, but it's very real. Just to talk about the picture on the left, which is just stock footage from one of our staff. When I was traveling to the conference here from home, a pickup truck went through one of the winter roads in northern Manitoba with a family in it. I argue that if they had perhaps had a better understanding when they laid out that road of the type of wetlands that they wanted to cross, they could have avoided that problem. Picture on the right, actually within about 5 years ago, north of the Paw, Manitoba, a guy went through a winter road with his feller buncher, and it fell on the door side. There was no escape hatch, and the individual drowned. So, I argue again that if there's some understanding of the wetland systems, we have an opportunity to reduce these kinds of things and improve our safety. So, using knowledge of wetlands as a decision support tool, by understanding wetland function and the location can be a helpful planning tool, and Paul's given a good example of that. But recognizing that wetlands are a dominant feature in the boreal, it's impossible to expect them to be avoided at all times. And so how can we incorporate this knowledge into developing practices that minimize or mitigate the influence of that activity? So I'll talk very, very briefly about our wetland classification system. Al is going to do a presentation that's more detailed. Paul's talked about it, but what's cool about it, from my perspective, is it separates out your organic wetland, which is your deep organic sites, versus your mineral systems. And we've actually classified up to 19 different types of wetlands of those two categories. It's a hierarchical system. You can organize it, peat wetlands versus mineral, What's missing is you can separate uplands from wetlands, so it's pretty flexible in the way that you organize the information if you understand what those individual wetlands are. Hence the reason for the classification field guide that Paul talked about. And incidentally, there's information in your handbook, in your handout material, where you can order that material, the guide. We realize that this is pretty complicated to the average Joe to expect an understanding of 19 different wetland types. So, and even classifying them can be challenging without experience. So what we did in the case of our roads is we thought, well, why don't we start to utilize our knowledge and group these wetlands into different flow characteristics, from stagnant to moving to inundated and flooded. And under the moving category, we have two moving laterally, which are our fen communities, and moving seasonally fluctuating being our swamps in particular. And how can we utilize this as a tool to guide the development of roads? So this is just a schematic on how that might look, with red being the most, so if you want to look at a risk of potential impact of hydrology of the wetland system, or the challenges that you might have with the road, your stagnant systems have the lowest risk, and then your inundated flooded systems would be of the highest. So we were fortunate enough to get a conservation grant from SFI, Louisiana Pacific, FP Innovations, Weyerhaeuser. There was another company that joined later on called Spruce Products. And we set forward to test this idea of using these groupings of wetlands to guide the construction of different crossings. It was great. Each group brought something different to the table. FP Innovations brought some engineering experience, as well as their experience in building roads in general. DU obvious. And then what was cool about the two companies, and actually it became three, is that they brought their perspective and experience of working with roads in that general area. Study area was in that straddled Manitoba-Saskatchewan border, and the whole idea was to use the knowledge of wetlands to inform road planning and construction, collaborate with the expertise of forestry professionals who plan and build roads. We had the guy in the back of the back who's running the backhoe participate in this. It was really, really cool. In fact, one quick story, the guy on the backhoe said to me when we were doing the monitoring, and there's a picture of the gentleman who did our monitoring, he said, how am I going to know that this works? Who do I talk to? I said, that guy over there with the long hair. He says, I want to know what I'm doing is an improvement. And I thought that was real engagement, and that was very cool. We had selected some field sites to test this. We engaged our research institute at Ducks Unlimited to do some monitoring, and then we provided recommendations. So we started off with sort of a textbook or a desktop assessment, looking at some literature to inform us. But the real key thing, we're doing wetlands workshops where we did the Wetlands 101 training, and we worked with these companies ahead of time and asked them to take us to sites where they were having problems, as well as places where they were not having problems, so that we could really have a discussion about why are you having a problem with this particular crossing and why is this one working. Incidentally, the picture on the lower left, that road was built very, very shortly prior to our field visits, and already water was starting to pile up against the shoulder of the road. Working with our partners, partner FP Innovations, and worked to develop some preliminary road crossing guidelines based on those three principal categories of stagnant and moving laterally and moving vertically and horizontally. And so this became sort of the template to build some test roads, and with the intent to match the wetland hydrology of the different wetlands that we had there. I want to point out that this was a field trial, but the primary objective was to allow the water to move under the road surface the entire length of the road. Bev is giving me the gears. So we ended up with three designs, as I said, stagnant right through to seasonally fluctuating. So we had selected three sites, two sites of the three different categories, and then we actually went and built them. And Paul did a really good job. This was the crossing that we did over a shrub swamp, and the first key thing was not to stump the road, keep the root mat intact, lay geotextile, integrate that with corduroy and pipe. Then the geotextile layer, which is a separation layer, and then we just end haul the road material. And the second one was through Conifer Swamp, which was built later. The same principle was applied, the combination of geotextile, pipe, and corduroy. But why I wanted this picture left in here is look at where the road surface is from the ground. And that's after traffic had been traveled along that road. So the ability to use this geotextile in combination with some other local materials really was an effective way of allowing water to move. In fact, more water was moving through the logs and through the culverts in one inspection. We did monitoring. Every single site had 12 monitoring location sites, 6 upstream, 6 downstream. Some were automated so we could go back and download the data. And in addition, water samples were collected so we could do some water chemistry assessments to look at changes in water quality. So let's just talk very briefly about the results. Under water movement, the crossings did not significantly impede water based on our trials. That's after only a couple of years of monitoring. The difference in water elevation upstream and downstream did occur, but you had a little bit of a recharge on the upstream side, but it dissipated very, very quickly as opposed to it being held there, which was typical of many roads that we'd seen. Under water quality, their water chemistry changes were detected immediately and adjacent to the road. And we attested that to the grading of the road and then the deposition of the soil from the road being deposited into the wetland adjacent to the road. And what was interesting, that water chemistry change was not detected at our monitoring sites, literally 20 meters on downstream. So it was very localized, and it tells us that you really need to think about good erosion protection. And one example that I think is a good one is you just extend your geotextile out a little bit farther from the road. In terms of the benefits, this is some of what we've learned from the operators that are building the road. That they've had no operational issues for 3 years. In one case, they had real problems with icing of the road, which became a safety issue. The culvert got frozen over time. Next thing you know, the water's flowing over the road. I'm not telling you guys anything new. Next thing you know, you got a safety challenge. The crossings, as built, worked well. They went on 2 different occasions, I was told by the operator, they're the driest part of the road, which is very surprising. And the benefit was reduced maintenance, for one, that they can access these roads sooner after wet weather, which allows them to get to their resource. So we delivered, there's a package in your handout where you can get all of this information. We cranked out some reports, field guides, operations guide. So those are available. And where we're at right now, we're working with FP Innovations on a national field guide handbook. It's going to be delivered, my understanding, through conversation yesterday, about mid this year. That's going to cover the entire country. It's not going to have the details, perhaps, of some of the work we've done in Manitoba because it's at a national level. That's going to be a deliverable. And the other thing is, getting a good wetland inventory. And although this is not as detailed as the work we're currently doing, there is a Canadian Wetland Inventory initiative taking off across the country. The blue is what's completed. The red is what's undergone, what's underway. And in Saskatchewan, within literally months, that will be completely blue, and Alberta will be completely blue, almost completely blue, except for, I think, the national park. So that's some work in terms of going forward. Bev mentioned reclamation. We think understanding how these wetlands function is going to only assist people that are going to have to reclaim these wetland sites. And then the other was winter road planning. And I really think there's something to this, doing some preliminary work. A couple of our staff have had a meeting, a field trip with Alpac last week, and starting to look at, freeze down. they're having trouble freezing down some of these wetlands. And so maybe utilizing this knowledge of how water moves across this landscape with these wetlands, that maybe they can alter the location of their winter roads so they freeze down quicker, get on the site earlier, and minimize the impact on the wetland. So it's really about achieving common goals. Further, the duck goal is a goal that is there for the industry, and it's a win-win situation from our perspective. And that's what we'd like to see going forward with all of our work.